Let's take a look at position versus time, velocity versus time, and acceleration versus time graphs. We also usually term these as motion graphs. So far, we have already seen that position versus time graphs, the slope of the position versus time graph gives us the velocity or how fast. So if you have uniform motion, the graph line is going to be linear, and linear graph means that it's constant slope, constant velocity, and in other words, uniform motion. So let's take a look at not linear graph. So in this case, it's a curve. Can't find the slope, but you can tell that the slope is changing, which means that the velocity is also changing. So if you find the slope of the tangent line, that gives you the instantaneous velocity or the velocity at that moment of time. And if you notice the slope of these lines, tangent lines are increasing, first decreasing and then increasing. So let's take a look at another example graph. Let's say we have this example graph and we understand it. First of all, the object is at a constant position, stays at the same place, and then the slope becomes negative, which means that the velocity is negative. Then we see the slope as 0, which means the velocity is 0. And then the third section is slope is positive, and the last one is slope is equal to 0. So if we have to predict how the graph for the velocity time graph will look like, we can kind of break it down into certain regions where we say changes happening. So when the constant position, the velocity is 0. So we can draw those all sections as on the x-axis because the velocity is 0. In order to show the velocity is negative, we have to go under the positive x-axis. And in order to show the positive velocity, we have to go above the x-axis. So velocity is basically the slope, which you can also see that it is changing suddenly in both graphs. Let's take a look at not so linear graph. Again, I'm going to mark some points on the graph, draw a tangent line, and kind of understand how the tangent line slope is looking. So if you look at the first two sections, it's positive. The middle one is 0, and then after that it becomes more negative slope. So if I translate it on velocity time graph, it starts with a positive velocity, then it decreases to 0, then it increases in the negative direction, and it becomes more negative. So it doesn't mean that it's decreasing, it means that it's becoming more negative. It's increasing or speeding up. Now we have a velocity time graph. And let's say it's a linear graph, which means that the velocity is increasing. If you look at the y-axis, the velocities are getting bigger and bigger. So if the velocity is increasing, it means that there is some acceleration or it's becoming more faster. And if we find the slope, rise over run, we can find out that it's the change in velocity divided by the time that it passes. And if you notice, this is the definition of acceleration. So what we can conclude is that slope of a velocity time graph is going to give you the acceleration of the object. So that's something to remember from the slope of a velocity time graph. Let's take a look at another velocity time graph and let's see if we can predict how the acceleration time graph is going to look like. Let's say we have a linear graph again. We can see the velocity is changing. The slope is constant, which means that there has to be some constant acceleration, or it is accelerating at a constant rate. So the graph will be a flat line. Let's take a look at another velocity time graph, and this time not linear graph. When we don't have a linear graph, we usually take points on the graph, we draw a tangent line, we look at the slopes of the tangent line to help us decide how the acceleration is going to be. So the slope of the tangent line will actually give you the acceleration. Here's another term that we can also calculate using the area under the curves. So let's take a look at a velocity time graph and use a simple example of linear graph. If we want to find the area under the curve, we just make it in a shape that we understand. The shape is a triangle. The area of a triangle is equal to half base time height. Now, if you look at this triangle, the base is the time that it takes measured in seconds, whereas the height of this triangle is the change in the velocity, which is measured in meters per second. So if you look at the units, your seconds gets cancelled and you're left with the units of meters, which means that area under the curve will give you the displacement. Let's take a look at a flat line for a graph. It does say that you're moving with constant velocity, but you're still moving, which means that you will be moved away from your starting point. So if I take the area under this curve, it's a shape of a rectangle, length times the width. The length is going to tell me the time that it takes, and the width is the velocity. So again, if I look at the units, I'm left with the units in meters, which means I can calculate the displacement from velocity time graph. Now again, remember, kinematic equations cannot be used if the acceleration is changing. And this is one of the scenario where the acceleration is changing, but you can do some calculations by using this type of graph to find the change in velocity by calculating the area under the curve. So that will give you the change in the velocity. If the area is above the horizontal x-axis, positive x-axis, you have positive change in velocity. If you have below the horizontal axis area, then it's going to be a negative change in velocity. So let's take a look at how we can summarize all this information in the form of a chart. We have three types of graphs that we looked at: position versus time, velocity versus time, and acceleration versus time. We did some calculations for the slopes. We saw that position versus time will help you find the velocity, and the velocity versus time will help you find the acceleration. Whereas the area under the curve was another type of calculations you can do, and with that calculation on the graph, you can actually use the velocity time graph to find the displacement, and acceleration versus time graph to find the change in velocity.